Hi, this video is the second part of my DIY bed leveling sensor build series. In the former video we assembled the 3D printed parts of the bed leveling sensor and we ended up with this object on the screen. In this video I will start to assemble the electronic parts to the PCB board. Let's get started. First of all, you will need the PCB board. The board design is available on GitHub, so you can download the schematics and the board, and you can send it somewhere where they can manufacture it. And next you will need an LM393 comparator chip, a 10K resistor 3 times, angled header pins, male header pins, 4 pieces, and the linear Hall effect sensor. First, we put the chip on the board. So I put it from the top and solder from the back. Once one pin is soldered, it's good to check if the chip is aligned to the board properly. If not, it's easy to format the solder on that pin and align it if needed. Okay, once the chip is soldered, we will put the pull-up resistor. Since all the resistors are 10K, it doesn't matter which resistor you put there. Now I have a little bit bigger resistor than what I used on the design, but you can put it like this, so it is standing up a little bit. I just solder from the back again, and I will clip the legs shorter. Right, so after the pull-up I will start soldering the voltage divider. So first resistor, same way as the pull-up. Just a little disclaimer here, so as you can see I'm not the master of soldering, so if you want to learn soldering, don't use this video for that. There are many better videos teaching you how to solder. Alright, so once the voltage divider resistors are there, I will start soldering the header. So I just take 4 pins out of the row. So I will also put this from the top. Actually all the parts are going from the top to the board except the Hall effect sensor. Now for me it's easier to solder one pin from the top. That will keep everything in place, so I can turn around and solder all the pins from the back. Alright, so here I'm just checking if the connector can slide on the pins. So there's nothing in the way and they are aligned fine. So now we will take the printed parts and I just remove the sliding rod. And I test fit the board on the pins or the toothpicks. Now this part of the printed parts is the part which will go up. So put it that way that the pins are pointing up. Okay, next I will take a 9-gram servo, and you can see the shaft of the servo is towards one side, and that will go to the upper part. Now I measure the cable I will need to reach to the servo pins on the board and cut the cable shorter. I try to remove now the board. Maybe it's a good idea to clip the toothpicks a bit shorter so it's easier to put on and remove the board. I just cut all the legs shorter on the bottom of the board so it will go a bit closer to the printed parts. Now I separate the 3 wires of the servo. The brown wire is the ground wire, the red one is 5 volts, and the orange one is the signal wire. Next I remove the insulation. You don't have to remove a lot, just a couple of millimeters really, and we will solder this straight to the board. So you need about that much. Okay, once the insulation is removed, I just put a little bit of solder on the wires and then start soldering from the top. So the wires go from the top and solder on the bottom. While I was doing this, I mixed up the wires, so I had to remove them and it was really a pain. But finally I sorted it out and everything is in the right order. I think this is where I realized that I messed it up. So I just desoldered the wire and put it to the right place. Alright, so this is how it should be at the end. So from the bottom towards the up, left to right, it's signal, 5 volts and ground. Alright, once the servo is soldered, I put back everything onto the printed parts. This is needed to align for aligning the Hall effect sensor. Now I managed to break a pin, which is not a big deal. So that's the broken pin. I will just glue the board to the corner. those upper pins are in a wrong place anyway, so it's really hard to handle them. Maybe in the next design we should figure out something else. So clip the toothpicks shorter and leave something like 3 millimeters above the board. We will need that to melt the toothpick and form a head above the board. But for now, just clip the toothpicks shorter. Okay, here I made another mistake, so don't do this at this phase. So I started to melt down the toothpicks. So don't do this yet, you should do it later, because now it is really, so if you cannot move the board up, it is really hard to align the Hall effect sensor later. So don't melt it down yet, just clip it shorter. Anyway, I left this in the video so you can see how I do the melting. So if you have all the 4 picks in place, then you can melt all the 4 of them later, not now. But if you have 3, that is enough, so no worries if you break one. So as I told earlier, the ones closer to the pins are tricky because they are partly under the pins. So those should be melted down really flush to the board. Otherwise they will be in the way of the connector. So that's what I'm doing now. I'm just melting it down and cutting the excess that may be in the way. But unfortunately later I have to break this one up because of the Hall effect sensor assembly. And I just apply a bit of super glue in the corner where I broke the pin. And that's it. So I think I will stop the video here. So I just I just test the connector. So I stopped the video here because it will be quite long otherwise. So in the next video I will continue with assembling the Hall effect sensor and putting the magnets in place. Thanks for watching. Bye.